Hello, Griffins. Video lecture number 8. Today we will look at bond type and the physical properties thereof. So this is really almost the lab pre-lecture. This is what we will be doing in lab. Testing, is the powder ionic or covalent based on the properties. Okay. So first off, ionic compounds, including of course polyatomic. Solubility means will it dissolve? Kool-Aid will dissolve in water, but will ionic compounds? The answer is yes. They actually prefer polar solvents, but water is actually fairly polar, even though it's um, covalent. So ionics will dissolve in water. Soluble, yes. But that isn't a telltale because some things that are not ionic dissolve in water. Here's a good one. Conductivity. So, ionic solids will form conductive solutions only. They are non-conductive in the solid form. So, something like calcium chloride is an ionic salt. If I have solid calcium chloride, it will not conduct electricity. But if I put it in water and get it to dissolve, that solution will conduct electricity. And this is a big one because covalence will not conduct at all. So ionics will conduct in liquid form, either melted or in solution. Very rarely do we ever melt an ionic solid. Melting points. Melting points are very high. High melting points, high boiling points, and this has to do with the interaction between all those positives and negatives. They really stick together really good. They're kind of sticky, we would say, and they want to hang out with each other. They don't want their neighbor going away, and because that electrostatic force is going on. So you got to overcome that with extra energy. High melting point, high boiling point. The crystal structure has a crystalline structure. So yes, crystalline structure. Yes, it's hard. Yes, it fractures. So if you think of like table salt and pretend you're hitting it with a hammer, it would shatter into powder. It wouldn't just mush like if you were hitting sugar. Like you hit sugar with a hammer, it's just kind of mush and stick together. Okay, it doesn't fracture. So now we're going to move on to covalent properties. See that word molecular right here? Just so we're clear, this is a code word. Ding, ding, ding. Molecular is code for covalent. These two things are synonymous. So if you see the word molecular compound, that means covalent compound. No wiggle room there. Solubility, slightly soluble in water, definitely soluble in nonpolar solvents. So what that means is some covalents will dissolve in water, but most don't. Okay, some are very waxy. Sugar is about the only one that does, but sugar is actually a really big molecule and it's got a particular end water will hang on to. Okay? Conductivity, this is the big test. Non-conductive no matter what. Not in solution, not in liquid form, not in solid form, not in gas form. Covalents do not have those pluses and minuses, so there's nothing for the electrons to attach onto and flow through. Okay, I got nothing that can act like an electron in a nonpolar molecule. I'm sorry, in a covalent molecule. Therefore, I have low melting points and boiling points. So you see I annotated that this time. You'll see MP and BP from now on, now that I gave it to you in full out words. MP, BP, boiling point, melting point. Well, backwards, but you got it. So very low, they don't like to stick together. They are soft, non-crystalline structure, and they do not fracture. They really do kind of mush. They don't cleave, if you will. They kind of just smush into each other. Okay. Last one, metallic compounds. Any kind of metallic bond is between a metal and another metal. So if it's a compound, it's something more like an alloy, like a mixture of two metals. We'll get into that in future units. But solubility, very insoluble. I can't get a metal to dissolve in water. Okay. Conductive, yes, but in the solid phase. So metals are the only ones that conduct in the solid phase. Those electrons exist in a mobile sea, and the electrons can actually move around. So that's how they're conductive there in the solid phase. Metals, of course, have high melting points and boiling points. It's very tough to melt, a gold ring. You got to get it really hot to get it back into liquid form and reform it. And they do have a lattice structure with that mobile sea of electrons. So the protons have definite arrangement in space. What's able to move around is the electrons, and that's what allows electricity to flow through it. Okay, good. So there is the physical properties. We can compare and contrast real quick. Covalent and ionic. Covalent is, of course, two nonmetals. Ding, ding, ding. They're very non-conductive. Number one test. They do have low melting points and boiling points. Number two test. Soft would be the least conclusive test we could do. Okay, hardness. Ionic compounds is a metal plus a nonmetal. They are conductive in solution. They have high melting points and boiling points, and they are fairly hard relatively. What these two both have in common, of course, is they are stable configurations because they have their full valence shell. That's why they bond to begin with. And they're a compound because they are different kinds of elements put in there together. So that's what they have in common. You have now some practice pages you can get through, 22, 23, and 24. You will need a periodic table for those. So make sure you have that handy, and Google Classroom to wrap it all up, and we are done. See you in class tomorrow. Loaded.